So that's actually something I want to remind you first before we get into the calculation. So we need to know what is a reference angle. All right, so that means, the worst case scenario is you don't remember all those tricks I'm going to teach you, then at least you can go by the definition. All right, so when you draw an angle and its terminal side is not in the first quadrant, all right, so then you start to worry because the angle is too big. And the reason why we think it's too big is because we want everything to be in a right triangle, right? You guys like the right triangle tricks, SOHCAHTOA stuff, right? We could transform any kind of a crazy angles into a acute angle and use our knowledge of a right angle trick. And that's why we're trying to find the reference angle. So all you have to do is find the angle that's made by the terminal side of an angle and the horizontal line. And that'll get you a positive, also acute angle. And that's for, therefore, let's say if the angle here, the big angle is 120. How much do you think will be the angle here, which is in between that terminal side and the horizontal line, and it's also acute? 60, right? So this is why I said if you know the definition, you draw an angle, you'll be able to find it, right? But sometimes, you could quickly add or subtract, some numbers to get it. Simply put, a reference angle has to be positive and acute. By acute, I mean, if it's a degree, it needs to be less than 90. If it's radians, it needs to be less than pi over 2. But just so you know, pi over 2, I mean, number-wise, it's 1.57. All right, keep that in mind. Right, if you compare numbers, then, work with pi at 3.14. So now, let's think about 11. Well, of course, 94 is greater than 90, right? So if you want to think an angle that's 94, so the terminal side is going to go past the y-axis just a little bit. But you'll easily find there is a small angle in between the terminal side and the horizontal line, right? So that will just be 86, right? If you draw it, right? So this big angle is 94. Therefore, you're finding the supplementary angle, which better be 86, right? You could do that. But what if I just bluntly, play with the, angle, let's say 180, because my goal is to try to get a small and acute angle. The reason why that 94 is not something I can take right away, because that is a bit too big, right? So the way to make it bit smaller is to go ahead and subtract 180. Well, of course, you're going to get negative 86, right? But now, the correct answer is 86. You're getting negative 86. Is there a way you can convince yourself that you could have just taken negative 86 and just lose the negative sign and just keep 86? Now, there are two ways to look at it. First, you're thinking, what is the best way to get an acute angle if you already have a negative acute angle? I'll say take the absolute value, right? Because you just want a positive, right? And this is like, say, if I have a big brother, he's 5'9", I'm 5'7". I'm trying to find a difference in our heights. So if I subtract my height from his height, I get 2 inches. But if I insist I subtract his height from my height, I get negative 2 inches. But all you want is a difference, right? So if you see a negative difference, take the absolute value. That's why you could have just taken the negative 86 and just lose the negative sign, and you see the same answer. That's, not an official way to do it, right? The official way to say is, well, you know what? Since you are looking for the difference And since we know that a positive difference is probably going to be more intuitive, right? That's why instead of subtracting 180 from 94, you should have subtract 94 from 180 in the first place, right? But again, I think that if you do know what the difference represents, so you won't be too crazy about the negative sign, right? Anyway, now let's try 12. But now we have something we have to deal with first. The angle is not just big, like bigger than 90. It's a bit too big, right? It's bigger than 360. Something that you have to do in general in trig when you see an angle which is negative or too big, right? Greater than 360. So you want to either add multiple of 360 or subtract multiple of 360 to bring that angle to a range of 0 to 360, right? And that's called finding the coterminal angles. And coterminal angles are all the same, but they're a lot nicer to deal with, right? So in this case, 432, before you think about getting the reference angle, why don't you just make it a little bit smaller in the sense of getting a smaller coterminal angle, right, by subtracting 360. And you're getting 72, right? But then you said, wait a second, isn't 72 exactly what I want? Because, I mean, yes, I wasn't trying to find the reference angle. I was trying to get a coterminal angle. But it just so happened this is also a reference angle. Because your goal, don't forget, you're trying to find an angle that is positive and acute. And this is already positive and acute, right? So therefore, that's it. Right? Now, 13, what if the angle is negative? Try not to think about reference angle right away. Just play the safe move, right? By adding 360 to make it positive first, right? So that's going to get you 99. Okay, so now you see that it's just like 11, right? You get 84, now it's 99. So what you can do is either by thinking about what that angle looks like, right, and find out the supplementary angle, or think about, you know what, this is still too big, right? To find a reference angle by making an angle smaller, I have to play with 180, right? So let's go ahead and subtract 180 from it to turn 99 into negative 81, right? And again, stop right there because you have a negative acute angle. All you want is a positive angle, right? Then just go ahead and take 81, right? Just lose the negative sign or take that as the value. Okay. Or of course, you would have seen that hey, that's only 81 degrees away from pi, right? Or away from 180, so it's gonna be 81 anyway. Right. So simply put, if you see an angle that's greater than 360 or negative, first make the angle positive by adding, subtracting 360. Once you're there, right, the angle is less than 360, think about how to make it small enough to be less than 90. But be alerted that you might end up getting a negative acute angle, and don't keep on going, right? Because you already got it, just take the absolute value. All right, so now, of course, when you have to deal with the radians, even though that you're supposed to apply the same skill, but it's harder to imagine what the angle looks like. So maybe it seems harder. Now, first off, I need to know if that angle is too big. It's not negative, right? What if it's too big? Maybe I should subtract, 2 pi from it right away, right? So now, is it too big, or like greater than 2 pi? 2 pi over 3. No, right? Just the way you say it, 2 pi over 3, that there's no way to greater than 2 pi. So it's less than 2 pi, so we're good. So now what I have to think about is how to make it smaller, right? So I'll just go ahead and subtract pi, right? And I'll get, now, unfortunately, you don't have a scientific calculator to do the fraction for you, so you just have to do it by hand or figure out a way to use the full function calculator to do it. I'll say that for easy ones, just do it by hand. So 2/3 minus 1, you get negative 1/3. So negative 1/3 pi, right? Shall we keep doing? Or you know what freaks out people is they realize, oh, it's a negative angle. You know, maybe I should just add 2 pi to make it positive. I mean, it depends on what you want to do, right? If you want to find a coterminal angle, yes. But remember, that wasn't our goal. Our goal is to find a positive acute angle, right? But I hope you realize, without a negative sign, pi over 3 is acute angle, right? You need to know that pi over 3, pi over 6, right? Pi over 3 is 60, right? Pi over 3 is 60. So this is already a negative acute angle. That means you just go ahead and take the absolute value. Right, and that's it. Right. So again, does it make sense that once you get negative pi over 3, you could just take the absolute value and conclude that this is reference angle? Does it make sense? Yeah, again, your goal is to get a positive acute angle. And that's pretty much it. Now, 17, it seems like, you know, that might just be a happy coincidence that you have the same exact reference angle as, you know, the one you got in 16, right? But I'll say that what are the odds in math that you get 2 different problems with the same answer? So I don't think it's going to be a coincidence. So now, why don't you think for a minute to sort of, hopefully it makes some sense that why that angle, which seems completely different from the one you had in 16, but have the same reference angle. 1 minute.
Why you touching it? What? Don't come here, buddy. Yeah. Which is cool.
All right, anyone figured out a way to explain to all of us that why positive 2 pi over 3 and negative 2 pi over 3 must have the same exact reference angle? Oh, yeah. Okay, but and how would you get a negative, you know, if you have negative 2 pi over 3? You add pi. Okay, so in subtracting pi, you add the pi, so you get a negative difference, which is negative pi over 3, but it's the same thing, right? Now, so that's a mathematical way, right? And it's actually very logical because as you're going through the math, you realize that it's the same exact process, right? Now, there's something else I want to share with you, and I think that I brought up the point in one of my, let's see, second, it's the first period. Wait, is Lucia in our first period? Lucia, yeah. Oh, she's in the second period. Okay, yeah. So one of my second period student, you know, was asking me, isn't that always the case? You know, what I thought is, oh, I never thought of that. Yes, right? So let's see if it makes sense to you. So she said, will opposite angles always have the same reference angle? So let's say in the future, if you get 1,000 degree, you figure out the reference angle. Then all of a sudden they say, hey, what is the reference angle of negative 1,000 degree? It'll be the same. And here's one way to see it. Wait, did I do that? Okay, anyway. So let's take this example to illustrate why the opposite angle is going to have the same reference angle. So 2 pi over 3, in which quadrant do you think it is in? 2 pi over 3. 1, 2, 3, 4. So the second quadrant, right? Now, if it's a little bit hard to imagine, you can turn that into degree. 2 pi over 3 converted to degree, it will be 120 degrees. Right, so it'll be the second quadrant. So this is 2 pi over 3. And of course, you see right away it has to be pi over 3 for the reference angle, right? But now, how do I draw the negative version? Instead of turning counterclockwise, I'll turn clockwise, right? So it will be reflected about the horizontal axis. So this is negative 2 pi over 3, right? And the angle of, this negative angle, the reference angle will be still 3 pi over 2, pi over 3. It is because we are only looking for the difference between the terminal side and the horizontal line. What the negative sign does is to flip that negative, the terminal side across the horizontal line. Just by symmetry, these opposite angles must have the same exact difference away from the horizontal line. Therefore, I didn't conclude for my second period class, but Lucia asked me if that's true, and I thought about it. I think that it is true. Opposite angles do have the same exact reference angles, and that's the way to prove it, right? So now, it's probably useless because I don't think you're going to be able to get a question just like that in a test, but it's something for you to think about, right? But that's exactly what I was talking about. Those are not conclusions you can find in a book, right? But those are the things that you gain as experience. It's like, you realize a lot of things you end up doing in your life might not be the first time that you were taught or like the correct way to do it, right? But you figure the best, the most efficient, effective way to do it. The same thing, right? May not be super, standard, right? Anyway, so I guess that now we're only worried about the last one, right? It is hard since it's radians, right? And it's confusing since people thought that it might be degree. Not to mention that it's just hard to picture an angle in radians. So 5.2 is measured in radians. But let me first check if it's going to be too big. And if it is, I better subtract 2 pi from it, right? So now how do I know that 5.2 is or is not too big? Right. So 2 pi is about 6 point something, right? This is obviously less than 6 point something, so we're good, right? So now I just have to think about make it smaller, right? And to make it smaller, to try to get the reference angle, you're going to subtract pi radians. Number-wise, it will be 5.2 minus 3.14, right? You're going to get 2.08. Am I right? Wait, am I doing this right? No, 2.06, right? Yeah, thank you. All right. Oh, yeah, it's right there. Now, the thing is, sometimes you saw that, oh, that's such a small angle, only 2 point something. But it's in radians, right? So it is not necessarily a small angle, but you never know whether, it's, really small enough, right? Because I want a acute angle. So what should I compare it to? See if it's already acute angle. 2.06 radians. Acute angle needs to be less than 90. Or in radians, it needs to be less than pi over 2. Pi is 3.14. Pi over 2 is 1.57, right? So 2 point something is greater than 1.57. So that means we have to do it again, right? Let's make that even smaller. 2.06 minus 3.14, right? So we're going to get negative 1.08, right? So now, hopefully you realize that you should stop and just take the absolute value because you already know that 1.57 is pi over 2. This 1.806 is already small enough, right? It's just negative, and just lose that negative sign, and there you have the reference angle. Right? Also, something that it might already seems obvious, but I just want to mention it in case that on a pressure that you probably forgot. Hey, there's no way you can get negative reference angles, right? So if you see a negative option like negative 1.06, right, OA, you're never going to pick that, right? But that's like a sanity check. If you know that you're looking for a reference angle and you happen to pick an answer that's negative, then you know there's something wrong. Anyway, so now I hope that you'll be 100% clear with how to find the reference angle, right? And also maybe take some shortcuts, right? Now, we have a few more problems for you guys to practice how to use the reference angle to evaluate trig functions, evaluate as some angles that you don't want to deal with. Let's see, we have, I think we should have time. So let me give you something like maybe 4 or 5 minutes to try these problems, except for 21. Don't worry about 21. All right, so I'll get to that, later. But maybe just try 19, 20, and 22. I'll give you maybe 6 minutes, just in case. But I'll go over them anyway. But just give it a try. But what you have to get by the end of the 6 minutes is the reference angle of all 3 columns. I'm sure that you'll be able to do that, right? But if you can get an answer, that will be great. Otherwise, at least get me the reference angles. If you don't remember, look up the notes, or if you have, well, I'll go over anyway. But try to recall how you use the reference angle. 1 minute. At least make sure you get the correct reference angles. I'll help you recall how to properly use it. All right, so let's go over them. But let's first figure out the reference angles first altogether. All right, the first one, pi over 3. So how would you find out a reference angle? Like, I want to know the strategy. So now tell me, like, you think that might be the smart way to do it? Okay. And I guess that's probably not enough, right? Once you do it. So we'll do 5 pi over 3, subtract the pi, you get 2 pi over 3, right? So the wall is still greater than 90. So I guess they're going to do another one, right? So, right. Yeah, you could have do like subtracted 2 pi, right? So now the reason why sometimes you might want to think about subtracting 2 pi is, see, the reference angle is nothing but the difference between the horizontal line and the terminal side, right? But sometimes it might be closer to 180. That's why you find the difference between the angle and 180. But it might be over the other side, right? It might be closer to 360. So be flexible. But the worst case scenario, if you realize, oh, I'm going to subtract a pi and then another pi, you have to be subtracting 2 pi, right? It's not going to cost you like too long, right? Maybe a couple more seconds, right? But in this case, it does make sense that maybe we should have just subtract 2 pi right away, and we get negative pi over 3, and that gets you the reference angle. Yeah, good. All right, we'll come back. All right. So now, what about this one, 20? Well, actually, we did it already, right? So after some math, right, you figured out the reference angle will just be pi over 3. Okay. Now the last one, 750. Now, can anyone tell me how you did that? Oh, by the way, the reference angle is supposed to be 30, right? Yeah, Maya, you want to share with us? Okay. It's 390, yeah. And do it again, right? So 390 minus 360, so you get 30 degree, right? Then you stop. Okay, good. Now, I'm glad that you guys figured it out, but let's think just a little bit more. What are we doing here? I keep subtracting 360. Were we trying to find the reference angle in the first place? I mean, we're trying to, but what we did was not trying to get a reference angle. We're trying to get a smaller angle, nicer to deal with, right? And now 390 is called the coterminal angle of 750. And 30 is also a coterminal angle of 750. Now, by adding, subtracting 2 pi, or adding, subtracting multiple of 360, we're finding coterminal angles. And we like to have coterminal angles that are small enough to deal with. So that means that is a happy coincidence that we were trying to find a coterminal to make it small, but it just so happened to be a reference angle. So don't get me wrong, because you might say, how come you don't subtract 180 anymore? Sometimes people might ask. The two different things you're doing. Adding, subtracting multiple 2 pi over 360 is not trying to find the reference angle. It's trying to make the angle small to make it fall into the range of 0 and 360. That's called coterminal. And that's safe. There's no way you can get it wrong because any coterminal angles are all the same. Right? But maybe just by finding the coterminal angle, you might end up getting a reference angle, right? And of course, that's good. Anyway, so now the reason why that 21 is tricky is, can you guys think of any angle that could be the reference angle of a negative pi over 2, which by the way is negative 90 degrees? There's no way you can do that, right? You can play with 360, 180, you're always going to end up being 90 degrees. But 90 is not a acute angle. That means negative pi over 2, technically speaking, does not have a reference angle, right? But it doesn't need a reference angle because it's one of those special angles that you could figure out right away. And let's do that since, that's a bit different than the other three questions. So I wanted to draw that angle. So where is negative pi over 2? The terminal side will be lined up with the negative y-axis, right? That means I'm going to pick a point right there, and I'm trying to think about what coordinates it better have. Well, since it's on the y-axis, the x-coordinate has to be 0, right? So what would you guys take as the y-coordinate of a point like that? The negative portion of the y-axis. It's going to be something negative, right? It's just like, what numbers you like? Negative 2, right? Well, you could do that. Well, I'll say that. Why don't you make it negative 1, right? So it'll be even easier. And you know what? In 5.4, you're going to deal with unit circle, and you'll see that the distance is going to be 1, right? But you still take negative 100. You're still going to get the same thing, right? So now the question is, do you guys still remember the XYR version of a definition of a tangent? So it might be a bit hard to think, but like I said, always picture a right triangle in the first quadrant, right? This is angle theta. The opposite, which is the vertical side, better be y. Horizontal is the x. Tangent is x, y over x, right? Opposite adjacent. So it's y over x. Will be negative 1 over 0, so it's undefined. Okay. So that's why 22 is not really checking the reference angle, but it doesn't really ask you for anything else that you haven't learned. Okay. Now, let's take a look at maybe 20. Right? I know that cosecant is your favorite for some reason. Now, here's the beauty of a reference angle. You get this kind of function evaluated at an angle that it's not that nice to deal with. But you can get pretty much the function evaluated at this reference angle. To replace it, but the price you pay is you have to figure out what is plus minus. Okay? Simply put, as long as you can find the reference angle, then whatever trig function evaluated at the original angle will be pretty much the function evaluated at the reference angle. The only difference is it might have a negative sign somewhere, sometimes. And to figure out that negative sign or not, use that quadrant thing. Think about the original angle. In which quadrant you think that negative 2 pi over 3 is located? So how does it work? It's going to turn clockwise, right? And I think that if you turn 90 degrees, you're going to end up being negative pi over 2, right? Keep turning, but you're not going to quite get to the horizontal line, since that's going to get you negative pi, right? So it will be somewhere between this and that. So it's negative pi over 2 and negative pi. So that will be negative 2 pi over 3. Now, if you're not that used to radians, do the degree. Take that 2 pi over 3, turn it into degree, it will be 120 degrees. 120, I mean, everyone can see that negative 120 is going to be in the third quadrant, right? Now, it's in the third quadrant. Cosecant is positive or negative? In the third quadrant. cosecant is negative because only tangent and cotangent is positive, right? A smart trig class, right? So it'd be negative. So now you know that you guys might like cosecant a lot better, but I like its reciprocal, right? It will be reciprocal by sine. But now pi over 3, it is one of those special angles, right? And I guess you guys realize I posted the cheat sheet on D2R last night. So I wish I could say that guys remember everything in it. I don't want to say that to stress you out, but the reality is the more you remember, the better off you are, right, in a test. Anyway, so you can choose to memorize that chart of all those special angles like a 30, 60, 45, right? But I'll say that maybe here's the better way to do it. So everyone, once you get the cheat, the spreadsheet, the paper, right, or the packet in a test, draw these two special triangles. One is the 30, 60, 90 triangle, and the other 45. You know, that's easier, right? Now for 30, the opposite is 1, the hypotenuse 2, the adjacent of 30 is radical 3, right? So now I'm looking at sine of pi over 3. You know that's going to be the same as sine 60 degree, right? So 60 degree, okay, opposite over hypotenuse. So it will be radical 3 over 2. But I want the reciprocal, right? So it'll be radical 2 over radical 3, right? And of course, they're not going to give you something like that, right? So you have to rationalize the denominator. You're going to get negative 2 radical 3 over 3, okay? So that's letter A. Now, with that triangle, 22 becomes trivial, right? So now we have tangent 750, which is either plus or minus tangent 30, right? So now the question is it positive or negative? So well, which quadrant is 750? 750, all right, so keep turning, right? 2 rounds and back to the first quadrant, right? But remember that we already did that. Do you remember that 30 was coterminal angle? That means it's the same as 750. So 30 is in the first quadrant, so it's the 750, right? But either way, you realize that it's a first quadrant. That means nothing's negative, right? So you're gonna go with tangent 30 in the right triangle up there. You know that 30 degree is opposite of adjacent. Okay, so it'll be 1 over radical 3, right? Rationalizing it, radical 3 over 3, right? There you go. All right, so I'll leave the screen like that, you know, for you to take a picture, or maybe keep an eye on the recording.